The conference paper we are going to present is on the study of groundwater contamination by heavy metals within cemetery environments. Two authors are involved in this research, Christopher Brownson, Afangideh, and Udokpoh. Both of us are from the Department of Civil Engineering, Akwa State University. The main presenter of this research work in this conference is Engineer Dr. C.B. Afangideh, and is the major author of the work, who is the one presenting the research work I earlier mentioned, the study of groundwater contamination by heavy metals within cemetery environments. Introduction. The potential threat for adverse impact of cemeteries on ground and shallow water has never received enough attention in Nigeria. In agricultural waste, industries and landfills are commonly believed to be the major anthropogenic sources of environmental contamination. People are so aware of that is the major waste. Therefore, the decomposition of human body at cemetery has never been considered at all to have a significant potential contaminant effect in the environment and even groundwater. Therefore, there's a rapid increase in urbanization has led to the establishment of cemeteries close to populations within the radius of influence of drinking water sources. And also several cemeteries have been sited without proper assessment on the geological and hydrogeological characteristics of sites, therefore posing environmental impact and public health risk. Cemeteries are not only the final resting place to bodies, but also to coffins and caskets used for the interment of remains. The material itself that are used in coffin making may corrode or degrade, releasing harmful toxic substances into surrounding soils through seepage and diffusion. Toxic chemicals that may be released into groundwater include substances that were used in embalming and burial practices in the past, varnishes, sealers and preservatives, and metal handles and ornaments used on wooden coffins. This research aims to investigate the level of soil and groundwater contamination within cemetery by burial practices and anthropogenic activities. In order to achieve this, the water and soil samples were subjected to various tests to know the heavy metals, physiochemical and biochemical properties. Materials and methods. Description of the study area. Udokpoh is a small village in Akpaden State and is located at 5 degrees north and 7 degrees east. The cemetery is located in the rainforest belt with the elevation of 1,000 millimeters above sea level. The climatic condition is warm, humid, high temperature, and heavy rain distribution almost all the year. It is because of the, especially due to this temperature elevation, make the decomposition of the buried human causes to decompose very rapidly, and therefore the cemetery covers a land area of about 90,000 square meters, and the cemetery is divided into two sections. One will be the fallow section, and the other one is the one that the continuous burial of human corpses take place. After when that place has been exhausted, they move into the other area that has been left fallow until they leave this portion for about 7 years fallow, until after about exhausting this former side, they go into the other side, which has remained fallow until they exhaust that area, and therefore the land area had been of use for several years with continuous burial on the previous ones, and that is how the place had been used. Collection and analysis of samples. 2 different samples were collected. Those were the water samples from different boreholes located at different intervals within the cemetery environment. And also the soil sample were also collected, which were taken from different depths, at the depth of 1 to 2 meter, up to 3 meter, different intervals. Both of these were to determine the level of heavy metal contaminations and physiochemical analysis and also the pH level and moisture contents. Apparatus and equipment used for the apparatus and equipment used for the analysis were boring auger, trowel and spade, sampling bottles, volumetric flask, measuring cylinder beakers, oven, pH meter, turbidity meter, filter paper, weighing balance, fume cupboard, hot plates, vacuum pump, standard buffer solution, pH which is 4.0 and 9.2, concentrated hydrochloric acids, spectro UV and VIS-RA spectrophotometer, and solar 969AA spectrometer were the apparatus used to for these experiments. Result and discussions. Table 1 shows the allowable limit of parameters in drinking water by Nigerian Standard for Drinking Water Quality, Federal Ministry of Environment and World Health Organization WHO standard. The laboratory result of physiochemical, biochemical, and heavy metal analysis are presented in the table 2. The results from laboratory analysis indicate that the level of contamination varies with distance. Sample A, which is the borehole water fetched approximately 50 meters, very close to the cemetery area, had the highest concentration of heavy metals. As you progress far away, different distance away from the cemetery, the level of heavy metal concentration became lower and lower as you go far away from the cemetery environment. Parameters of borehole water sample A, B, and C collected at approximately 50 meters, 100 meters, and 200 meters were not the permissible limit for drinking water as recommended by WHO and NADWQ. A control sample F was obtained as stretched the cemetery environment. The level of concentration were far less compared to sample within the range of 500 meters, which indicate that cemeteries might constitute potential sources of contamination of groundwater. Result and discussion in table 1, the standard limit for parameter for the 3 agencies, which I had earlier mentioned, NADWQ and FMENV and WHO. Different parameters have been listed. pH level, which is for NADWQ and FMENV and WHO, and also the turbidity and BOD. All of them, the standard analysis data has been listed in table 1. Result and discussion in continuation with the standard limit for the safe water, and different heavy metals lead has a limit that you expect it from the water you may be consumed. That it should be in 0.5 and 0.5 for WHO standard, and that of vapor is just the same 0.5 and so on. If you look at the zinc, it's just WHO standard limit is 3, and also other ones FMW 1.0, and also mercury in WHO it has the limit should not be less than 0.001, and so on with other bodies, the standard, other standard organization. I think we can do that. The results of laboratory analysis for the borehole water samples, and the sample A, B, C, D, E, F were at different distance away from the cemetery. A was 50 meters away from cemetery, B was 100 meters away from cemetery, C was about 200 meters up to the last one, which was F. And different parameters that were subjected for tests in this lab were the pH level, salinity test, alkalinity test, turbidity, a specific gravity, TDS and BOD, nitrate and phosphate were different tests that were subjected in the lab to determine the level of contaminations of heavy metals and all this we had earlier mentioned. In continuation, other heavy metals were also tested at different distances, and those heavy metals were lead, cyanide, chromium, zinc, copper, and as well as mercury. Different heavy metals were also tested at different distances to determine the level of contaminations. And at the end of it, we featured the whole analysis in table 2. In conclusion, to summarize the whole work that we have done, the study revealed that water samples from boreholes A, B, C, D, and E were slightly acidic. The results obtained for pH from this study were all low, which was 4.98 to 5.22, than the limit of the WHO standard. There were also significant variations in the pH level from one borehole to the other. Parameters such as salinity, alkalinity, turbidity, TDS and BOD analysis for the boreholes water sample within the study area were higher than the permissible limit. There were decrease in concentration of this element in boreholes cited some distances away from the cemetery. Concentration of various metals for the borehole in the study area was high. In my conclusion, the values were higher than WHO guideline for lead, cadmium, chromium, and many heavy metals, including mercury. These results obtained have made us to conclude that cemeteries may contribute to groundwater contaminations. The minimum distance is from cemetery to where potable water should be drawn. It should not be less than 250 meters as proposed by WHO. The distance should be greater in siting with steep hydrogeological gradients or soil with high water permeability. Similar studies should be carried out at other cemeteries. Such studies should also establish if potential contamination within cemeteries is higher compared to landfill sites.